Hello and welcome to Matrices. So Matrices is the first of the optional modules. There's 4 optional modules, of which ordinarily we only have to do 2, and we are doing the Matrices module. So chapter 11, which is starting off with matrices. Now, a lot of you probably remember a lot of this from general maths, or a little bit you might do in year 10. Okay, so let's get into it. So, what is a matrix? A matrix is a way of organizing information into rows and columns. Okay, rows, make sure we're talking about things, so rows and columns. Okay, so columns are the vertical things and rows are horizontal. Okay, they're a way of organizing information. We can show information in them. So we also enclose a matrix in the square brackets. You have to have square brackets. Okay, that is the accepted way of showing it. That's the convention that we use to show it. So any other type of bracket will not be accepted. And if you don't have any brackets, then definitely not accepted. Okay, you have to have the square brackets. So the number of rows and columns in the matrix tells us the order of the matrix. So this basically tells us the size, okay, the order. So we can say it's 2 rows and 3 columns is a 2 by 3 matrix, and it's always row first, then column. Okay, it's always row, then column. That's a very common mistake to confuse those. So when we say it out loud, we don't say 3 times or 2 times 3, we say 2 by 3. Okay, so that's just a convention of how we talk about it. Each individual item in the matrix is called an element. So that there is an element. Okay, it's one individual, item within a matrix. Okay, we represent the position, so we say where in the matrix that element is by using the notation A, IJ. A is the name of the matrix. So when we give matrix a name, we can say matrix A, we'd use capital letters. But when we're talking about an actual element, we use lowercase a. We just do. Okay, no real reason. We just do. And I represents the row number and J represents column number. So you can see here, that one there, that is representing row 3, column 2. Okay, so that's how we say where it is. Okay, that's to indicate the position, to make it clear where in the matrix it is. So, row matrices. If we've only got 1 row and many columns, we call it a row matrix. Sometimes some texts might refer to them as a row vector. So watch out for that if you're looking at some other textbooks and other sources. So here I've got matrix A. I've got 3 columns there, but 1 row, so it's a row matrix. Column matrices have 1 column and many rows. So again, column matrix, or sometimes column vector. And I've got matrix W there with 3 rows and 1 column. I could have many rows, but 1 column. Okay, the transpose of a matrix. The transpose of a matrix. So trans generally means, to change. So like transplant, transport, we're sort of moving or changing. So we are switching things. So when the columns and rows of a matrix are switched, it is called a transpose of a matrix. So here I've got this 2-row, 3-column matrix. We transpose it into a 3-row, 2-column matrix. So I've swapped the number of rows with the number of columns, and I've swapped the number of columns for the number of rows. Okay, so the transpose of a 2x3 matrix is a 3x2. And we use that symbol T to show transpose. So you can see it written out there. 35, 67, 24, T. And we've got it there. So working through how these are transposed here. Okay, let's not look at this first one. Let's look at this one here. So that is, that is originally row 1, column 2. That 3 now, where is it? It's row 2, column 1. So that's how we've switched it up. That row and column have literally switched. Look again at the 5. At the 5, you can see that 5 is row 1, column 3, and now it's row 3, column 1. And one more, I might do this 2. You can see it's row 2, column 1, and now it's row 1, column 2. Okay, so we've literally switched them all up. Yes, you can do that on your calculator. Nice, simple way. So I go into it later in my notes, but our matrix is here. Okay, next to the book we have, oops, what have I done? Sorry, I just had to restart my CAS program. As I was saying, if we hit this little button here next to the book, we come up with all these nice templates. Okay, lovely, lovely little templates to use. And if we come down here, we've got a number of matrix templates to use. So a lot of the more popular matrices, the 2x2 square matrix, the 1x2 and the 2x1, they're very popular. And there's this one, which is the one where you can put in however many rows or columns that you wish. Starts off with a 3x3. So I might just do the example. So 2 rows, 3 columns. Okay, and it gives us our template. One. Now I find the easiest way to move from element to element is to use the tab, because it just moves us through. Tab 6. Okay, now I want to do the transpose of that. So menu, matrix and vector, transpose. You'll see the little T there, and I hit enter. Oh, there we go. There it is. Okay. So this is from the 2019 Northern Hemisphere exam, so exam 1. In matrix A, element A21 is 7. So remember, that's row 2, column 1. The order of the matrix of A is 3 by 2. Matrix B is the transpose of matrix A. Matrix B could be. Okay, so we know that matrix A is 3 by 2. Therefore, matrix B must be 2 by 3. Okay, 2 rows by 3, so bang, bang, immediately. Okay, because they are 3 by 2s. So, we also know that element 21 is equal to 7. So, that means matrix B1, 2 must be equal to 7. So, row 1, column 2, 7. So that's B. And yes, we're correct. By the way, this is the question 3. In the modules, there are 8 multiple choice questions, and they get harder as you go along. So the first 2 or 3 are relatively straightforward. Then the middle ones, like questions 4, 5, maybe 6, are sort of medium hard, and then 7 and 8 are quite hard, can be quite hard. So always look for what question number it is. That will give you some kind of indication of difficulty level. Okay, square matrix. A square matrix is a matrix with an equal number of rows and columns, because it basically looks like a square. Okay, so I've given you an example of a 2 by 2, 3 by 3. Could have also done a 4 by 4, 5 by 5, etc., etc. They are all square matrices. We deal a lot with square matrices, so be aware of what they are. A diagonal matrix is a special kind of square matrix where all elements are 0 except for the leading diagonal. Now this leading diagonal, you can see here, is that sort of diagonal in the middle there, you know, from top left hand corner to bottom right, and it's always that direction. Okay, that's the way that diagonal is. Okay, that's the leading diagonal. You know, never that way, always that way. So again, I could have also put in a 4 by 4. I'm going to use very simple numbers because can't be creative right at the moment. You can see there that all the other elements are 0 apart from that leading diagonal. Okay, apart from that leading diagonal. So identity matrices, these again are very important. They're a special kind of diagonal matrix where all the diagonals, the elements on that diagonal are 1. Okay, we call that the identity matrix, and we use the symbol I. Okay, capital I. You can see I've got lots of examples there. The identity matrix is again a very important type of square matrix. We use it a lot. But yes, that leading diagonal, all the values are 1, and because it's a diagonal matrix, all the other values are 0. Symmetric matrices. So a symmetric matrix is a square matrix that's unchanged by transposition. So if you swapped rows and columns, it doesn't matter, you'll end up with the same number in the same spot. In a symmetric matrix, the elements above the leading diagonal are a mirror image of the elements below. So this has to be a square matrix. So, because a square matrix is the same number of rows and columns, this is a 3 by 3 here. This is a 3 by 3. So, transposing that, I'd still get a 3 by 3. So that, doesn't matter. Now remember, this doesn't apply to all square matrices. But you can see here, imagine that leading diagonal as a mirror. Okay, and you can see that they reflect on either side of that leading diagonal. Next, we have triangular matrices. So there are two types. We've got an upper and a lower. Now, students can get a bit confused which is which, so definitely this should be in your, everything should be in your bound reference, but make sure that you have this clearly in there. So an upper triangular matrix is a square matrix in which all the elements below the leading diagonal are zeros. So this is an upper triangular matrix because all of the elements below the leading diagonal are zeros, while the ones above are not zero. This one is a lower triangular matrix because all the values above the leading diagonal are zero, and the ones below are non-zero. Yes, we've got 1 0 in there, but we need all of them above to be non-zero for this to be a lower triangular matrix. That's what we're looking at. So I've got here the 2018 Northern Hemisphere Exam 1. You can see this is a question one, so it's considered very straightforward. So the matrix, we've got 1 0 0 5 1 0 8 5 1 is an example of what type of matrix is it? It's a triangular matrix because all the elements above that leading diagonal is zero. It's not symmetrical because it's not the same on either side of the leading diagonal. It's not a diagonal because a diagonal matrix only has elements on the diagonal and zeros everywhere else. It's not a communication matrix because we tend to have more numbers elsewhere, and also 8 doesn't make any sense. But yeah, it's a triangular matrix. And here we go. To enter matrices on your CAS calculator. So, yep, your little thing brings it up. You choose one. Yeah. Now, a good convention to get into when you are using matrices, especially if you're going to use them a lot, is to actually assign them to a variable. So matrices, are a bit of a pain to put in repeatedly, especially the big ones. So if you're going to use a matrix a lot, it's a really good idea to store it. save it as a variable. So control variable is storing, that little arrow there, and I might just call it A, enter. So that means if I want to use that matrix again, I just type in A and I can see it's a variable because it's bold, and hit enter, there it is. So A and menu 7 transpose. So I could be doing all sorts of things with it. So that's a really good habit to get into, is to be assigning your matrix to a variable name. Now, another good habit to get into is, especially if you are working and you end up with lots and lots of tabs, that's not a great idea, but menu actions, delete variable. So if you want to delete a particular variable, so I'm going to delete that variable A. And now if I type in A, you can see it's not a variable, doesn't know what it is. You could see there that you could clear any A to Z if you'd assigned those names to it. So a lot of times we tend to reuse matrix names, so you might want to delete variables every now and again, but best off to, once a problem is done, maybe start a new problem or a new document. Okay, stop this one here.